Okay, good morning, good afternoon, good evening, wherever you are in the world. Thank you for taking time to attend. On behalf of All India Oracle Users Group, very warm welcome to AIOG weekly webinar series. Um, as you know, this is a Oracle ACE Tech Talk series. The purpose of this webinar is bringing the Oracle ACEs across the globe. Today, you can see Arslan joined from Poland. Usually, we are trying to bring the ACEs from different parts of the globe and share the knowledge, right? And if you don't know about ACE program, just go to ace.oracle.com. And this is a program, it's a global program, recognizes and rewards individuals for contributing to the Oracle community. And you can contribute in various forums like speaking at conferences, writing blogs, contributing in forums like community.oracle.com, and also not the least volunteering in Oracle users group, like for example, volunteering in All India Oracle users group and organizing conferences, meetup, many things, and you also get a lot of benefits. You can see that in the website, but on high level, your profile will be published in ACE in oracle.com and exclusive content access to from the Oracle products, and also some goodies, and also Oracle Cloud account with worth of $5,000. Participate in Oracle beta programs and direct connections with product managers, whatnot. It's so much, right? So also you get a ticket to Oracle Cloud World, Las Vegas, so many more. So today's webinar, we have some few housekeeping. I'm sure most of you know, but still, many people doesn't follow the rules. And please ask your questions in the Q&A only. And if you have any other general questions about users group, please ask in the chat. And thanks to speakers by just doing a thanks in social media, taking screenshots. Also, presentation material and webinars will be uploaded as soon as possible. And also join us to get latest and greatest about AIoT, what's coming. And we have a mega event is coming in July. We are happy to see we already crossed around 750 registrations, and love to be part of this program. So please join us, and we may close the registrations. Okay, so because these venues have a limited capacities, please register, don't delay for the last minute. And with that, today we have Arslan joining from Poland, and he's currently is an Oracle DBA team lead, and he manages complex Unix-based Oracle databases for mission-critical applications. He comes with 23 years of experience in database administration. He developed and high availability performance tuning systems, and is very good in performance tuning, troubleshooting Oracle Rack, Data Guard, and many things, right? As you can see, he's an Oracle Ace Pro. And also we wish to see him an Oracle Ace Director, which is next level. And also he got a lot of awards. One of this prominent one is most valued contributor. So with that, thank you so much, Arslan, joining from your early morning. The stage is yours, and you can
Hello, Sai. Hello,
yeah,
everyone.
share your screen and yeah.
Cheers. Yeah, that's visible.
Yeah, we can see your I mean, AIOG website. If you go to your presentation,
Oh, okay.
yeah, perfect. We can see that. Go ahead. Thank you.
Thank you. Hello, everyone. Good morning. Good evening. Thank you for coming. I'm honored to be with you today. My name is Arslan. Thank you for Sai to introduce me. Uh, accomplished Oracle Data is administrator with 23 years of experience in the optimization and management of complex business critical Oracle database ecosystems. And today we'll be taking a deep dive into a powerful feature with Oracle's uh, globally distributed database Raft Replication. Over the next 60 minutes, we'll explore how Oracle leverages the Raft consensus algorithm to provide robust built-in high availability and fault tolerance for sharded environment, simplifying operations and guaranteeing data integrity. Here is what we'll cover today. We'll start by understanding the challenges Raft replication addresses. Then we'll introduce the solution and its core benefits, followed by a detailed look at the underlying concepts like replication unit and rough groups. We'll see how to enable it and discuss key GDS-CTL commands for day-to-day management and scaling. A crucial part will be understand the automated failover mechanism. We'll touch upon tuning and monitoring, acknowledge the current limitation, and summarize the key takeaways before opening the floor for questions. Modern applications demand databases that are not only scalable but also high available and resilient. Sharding addresses scalability but introduce the challenges in maintaining data consistency across distributed nodes, especially during failures. Traditional HA solutions often involve complex configuration like managing separate standby databases for each shard using tools like data guard, adding significant operational overhead. The key challenge is achieving automatic fault tolerance with guaranteed data integrity without burdening administrators and developers. Oracle Raft Replications is the answer to these challenges within the globally distributed database framework, specifically for system managed sharding. It uses the well-established Raft consensus algorithm, but tightly integrates it with the database transaction processing. Uh, this integration delivers significant benefits, granted zero data loss because commits require Chrome acknowledgement, very fast automated failover, and efficient active-active model where all shards worked, transparency for applications, and much simpler management compared to traditional HA methods at the shard level. Let's break down the core components. Data is physically divided into chunks, which are groups of partition. Raft replication groups these chunks logically into replication units and or RUs. Think of an RU as a set of data that will always be replicated together. Each RU has multiple physical copies of its data called replicas distributed across different shards for redundancy, as you see in the slide. The replicas within RU form a Raft group operating under the Raft protocol. Within each group, one replica is dynamically elected as the leader, right? It is a single point for rights for that specific RU's data. The other replica are followers. They passively receive changes from the leader. Optionally, they can be configured to serve read request for this distributing load. Crucially, a single shard isn't just a primary or a standby. It plays both roles, leader for some RUs, followers for others. This active participation across all shards ensures efficient resource utilization. The replication factor or RF defines how many copies of each RU's data exist. This directly impact fault tolerance. For any operation requiring consensus like committing a transaction, Chrome and majority of replicas must agree. For RF3, the Chrome is 2. Currently, Oracle's implementation fixes the RF at 3. This means each RU has one leader and two followers, and the system it can tolerate the failures of any single replica within that RU while maintaining availability for writes. This RF3 setting applies to all RUs across the entire distributed databases. Each RU maintains its own raft log on its replicas. This isn't the standard Redwood log. It contains logical changes specific to raft replications. The commit process is key to the zero data loss guarantee. Let's walk through it. In the Oracle Raft replication process, the client initiate by sending a commit command. The leader node then writes this commit record to its local Raft log. Okay, subsequently, the leader disseminates the commit record to the follower leader. Upon receiving it, the follower nodes write the commit record to their respective local rough logs and use an acknowledgement back to the leader. Once the leader receives acknowledgements from Chrome of nodes, it then acknowledges this successful commit back to the client. Okay. Only when the leader knows the Chrome of replicas have durably stored the commit record does it confirm the commit to the application. This ensures that commit acknowledgement is synchronous across the Chrome. The actual application of the data changes on the followers happens asynchronously in the background to keep transaction latency low. Enabling Raft is straightforward. It is a parameter during the initial shard catalog setup using GDS-CTL. Just specify repl native. Remember the key prerequisites you need at at least three shards to form a chrome with RF3, and it only works with system managed sharding, not user defined. A critical point, Raft Replication secures your sharded application data. The central shard catalog database still needs to its own HA solution, typically Oracle Data Guard. For through high availability, we need to ensure that the failure of a single component, like a server rack, doesn't take off multiple replicas of the same RU. Oracle GDL-CTL supports rack awareness. Okay, when you add shards, you can specify a rack identifier using the rack option, right? GDS-CTL then uses this information during deployment to ensure that the leader and followers for any given RU are placed on shards located in different rack, maximizing resilience. As the diagram shows, even if rack form fail, RU remains available because its other replica are in rack 2 or and rack 3. Once Raft is running, you'll need to monitor it. The primary command is status RU is in GDS-CTL. This shows you which shard is the current leader for each RU, who the followers are, their status and replication, lag information via LSNs. You can view all RUs or drill down into a specific one using the RU option. This is your first step for checking the health of the replication topology. Okay. Uh, Scaling your sharded database with Raft replication is managed via GDS-CTL. Adding a shard is relatively simple, uh, and it optionally specifying its rack and then deploy. By default, Oracle will automatically rebalance data and leader roles onto the new shard. You can defer this automatic rebalancing using no rebalance if you prefer manual control. Removing a shard requires more steps to ensure data safety. You must first manually remove all leader and follower roles of the shard using switchover RU and move RU before actually removing the shard definition. Afterwards, you might need to consolidate data using relocate chunk. GDS-CTL provides fine-grained control over replica placement and leadership. Move RU allows you to relocate a follower replica, perhaps to evacuate a shard for maintenance or to improve physical locality. Switchover RU is used to explicitly change the leader. You can designate a specific follower to take over, or you can ask GDS-CTL to automatically rebalance leadership across the cluster. Copy RU is essential for initializing a new follower, replica, or repairing one that has fallen to for behind or become corrupted by copying data from a healthy peer. Sometimes you need to move data between replication units, perhaps after splitting a large chunk, split chunk, to better balance data volume across RU. For this, use relocate chunk. It moves a chunk from a source RU to a target RU. Uh, the key constraint here is that both the source and target RU must currently have their replicas residing on the exact same set of physical shards. If they don't, you'd need to use move RU or switch over RU first to align their topologies before relocating the chunk. Importantly, the older move chunk command used in non-rough sharding is not applicable here. This where Raft replication truly shines, automated failure handling. What happens if the leader for an RU fails? The followers quickly detect the absence of the leader, run an election based on Raft protocol, and promote one themselves to be the new leader, provided a majority are still online. The system automatically update the routing formation and smart clients transparently redirect subsequent requests for that RU's data to the new leader shard. The result a very fast automated failover with minimal disruption to the application, often completed in under 3 seconds in low latency networks. What about the follower failures? If a follower fails, the leader notices but continues operating normally as long as Chrome remains. The RU stays available for writes. The leader will keep trying to contact the failed follower. If the follower is permanently lost, an administrator can provision a replacement using copy RU. And what happened when failed node comes back online? It it automatically discovers the current leader, catches up on any missed log entries, and rejoin the group as a follower. It doesn't automatically claim leadership. Failback is uh, seamless, and the system remains uh, stable. Leadership rebalancing can be done manually if desired. While Raft is largely automatic, there are tuning and monitoring aspects. Okay, you can decide per shard whether followers should serve read requests using a shard enable Raft follower read parameter, a trade-off between load balancing and read consistencies. Okay. GDS-CTL allows tuning a specific Raft parameter per RU, like the transaction commit, timeouts, or follow control mechanisms to manage replication speed. And importantly, Oracle provides several dynamic performance view with dollar for in-depth monitoring of RU status, log activity, apply log, and transaction states. When deploying a Raft replication environment with high network latency, such as geographically distributed cluster, specific parameters need carefully tuning to maintain stability and performance. First, shard HP loss. This hidden parameter dictates the timeout before a follower node considers the current leader to be unavailable, right? In high latency situations, network delays can be mistaken for a leader failure if this timeout is too short. Therefore, increasing these parameters allows the system to tolerate more network variance. A general guideline is set the associated election timeout to at least 10 times the round trip time between your nodes. For instance, with an RTT of 150 to 200 milliseconds, shard HP loss value of 2 seconds would be appropriate. Okay. It is absolutely crucial that this parameter is set identically on all nodes in the Raft cluster to prevent inconsistencies and potential value is equal. Second, heartbeat interval US. This hidden parameter controls how frequently nodes send heartbeat messages to each other, specified in microseconds. The ideal setting for this interval is typically between 0.5 and 1.5 times the network RTT. If your set is too low, you risk generating excessive network traffic and consuming unnecessary CPU resources on all nodes. Conversely, if it's set too high, the system will take longer to detect actual leader failures, thereby increasing the duration of leader election and potential downtime. The example command shows setting it to 20 milliseconds, right? It is important to be aware of the current limitations. The biggest one is the fixed replication factor of 3. This means it is to handle a single replica failure per RU at a time. It is only for system managed sharding, and remember that the shard catalog needs its own HA. Operationally, use relocate chunk instead of the old move chunk, and architecturally, while providing the synchronous nature of commit acknowledgement inherently adds some making latency reliable network between. So let's summarize the key advantage and in through built-in high availability that simply integrates into the database. It guarantees zero data loss through its synchronous commit mechanism. Failover is fast and fully automated, drastically reducing downtime and manual intervention. This significantly simplifies management compared to setting up and maintaining separate HI for every shard. The active-active model ensures all your hardware is working efficiently and entire process is largely transparent to applications. It is a robust solution built in on the solid foundation of Raft algorithm tailored for the Oracle ecosystem. Okay. In conclusion, Oracle Raft Replication is a significant advancement for achieving high availability within the globally distributed database. It delivers on the critical promise of zero data loss and fast automatic recovery from failure while simplifying the operational landscape through automation and efficient active design. This make the compelling foundation for building resilient and scalable application that leverage Oracle's sharding capabilities. Right? Uh, as automation side, so what exactly is Oracle ACE program? It is far more than just an award. It is vibrant global family of over 400 passionate technical experts, community builders, and thought leaders. There are individuals perhaps just like you, who love to share their knowledge, whether through blogging, speaking at conferences, mentoring newcomers, or creating incredible open source tools. The program formally recognizes and rewards this valuable community contribution across three tier Oracle ACE Associate, ACE Pro, and ACE Director. Thank you for your time and attention. I would now be happy to answer any question you may have. Thank you, Sai, for organizing this webinar.
Hey, thank you, Aslan. Team, any questions, please ask in the chat.
I don't, okay.
Sorry, not in the chat, Q&A.
Any question?
Yeah, maybe no questions. Anyway, thank you
Good,
so much.
good.
Thank you so
Thank you
much,
so much.
Aslan, for your presentation. What's coming next? So we have the last webinar from Stefan, and also you see the new webinars. We will post it in the during the weekend. And also, as I mentioned, so we have a big program coming in July. Please register in early bird offer. Please do not keep it for last minute. I know it's in July, but it's very important. So we are bringing a lot of experts this time. Look at the website, look at the speakers, and also share with your connections. With that, thank you so much today for attending this webinar. And special thanks to Arsalan joining us in the morning
Thank
and
you. It was my
presenting.
pleasure. Thank you so much.